All right, let's dive straight into this explainer and see exactly how combining mini program containers with custom plugins is completely revolutionizing rapid app development. Look, we're right in the middle of a massive shift in how software gets built. We are moving away from those rigid, clunky applications and heading straight toward dynamic, ever-evolving ecosystems. So if you've ever wondered how the world's biggest platforms can just roll out complex new features overnight without ever making you download an update, you are definitely in the right place. Here is our quick roadmap for today's explainer. We'll start with the evolution of plugins, look at why this architecture is so crucial, and then break down the modern app dilemma. After that, we'll get into hybrid mini-program solutions, see how to build super apps with FinClip, and wrap up with the future of assembled apps. Section 1. The evolution of plugins, from mainframes right up to mobile. Now, the core idea behind a plugin, extending a system's capabilities without actually breaking the core system itself, is surprisingly old. It actually dates all the way back to the mid-1970s. Back then, if you were using EDT text editors on those massive UNIVAC 9060 mainframes running the Unisys VS9 OS, they had this feature that allowed external programs to tap directly into the editor's memory buffer. It was totally groundbreaking because the editor and the plugin were sharing the exact same workspace. Fast forward to the 2000s, and we get the standardization of script and COM plugins. And now, in the 2020s, these rapid advancements in layered, plugin-driven tech are exactly what's powering today's mobile super app ecosystems. Moving right along to Section 2, why plugin architecture matters. This really is the foundation of flexibility. So today, developers are basically choosing between two main types of plugins. First up, you have script plugins, which often use XML. Now, people love these because they are super simple and highly accessible, but the catch is they can sometimes introduce some security risk vulnerabilities. Then, on the flip side, you have the component object model, or COM plugins. With COM, you get direct interfaces, meaning you don't even need to know how the plugin was built under the hood to actually use it. This seamless communication is exactly why COM is the most widely used plugin type on the market today. When you use this plugin architecture, you get some incredible benefits. Think of your software like a computer motherboard. The whole structure becomes crystal clear. Because the components are totally isolated, the coupling between them is incredibly low. You can swap, add, or delete plugins, just like snapping in a new graphics card. That makes maintenance an absolute breeze and unlocks massive code reuse. You can even patch the app dynamically while it's still in development. And hey, if your team is short on time or resources, you can just build the main shell yourself and let third-party vendors handle developing the individual plugins. Which brings us to Section 3, the modern app dilemma. It's a classic tug-of-war between performance and iteration. Look, developers face a really brutal choice every single day. If you build a purely native app, your performance is going to be incredible, but your iteration speed is painfully slow because you're always waiting on App Store reviews. On the other hand, embedding HTML5 web pages gives you lightning-fast updates, but it completely tanks the user experience with low performance and very shallow system permissions. But then there's the third option, mini app development. This completely changes the game. It takes the ultra-high performance and deep permissions of native development and marries them perfectly with the rapid iteration speeds of HTML5. And that leads us perfectly into Section 4, hybrid mini-program solutions, getting the absolute best of both worlds. This hybrid approach is the ultimate problem solver. What you should really take away from this is just how powerful the native plus mini-program combination truly is. You literally write one set of code and it runs beautifully across both iOS and Android. Plus, because it bypasses standard window and document objects entirely, you completely eliminate those nasty DOM memory leaks that are famous for crashing standard web apps. Not only does this keep your overall app download size nice and small, but it allows you to push instant, hot updates straight to your users without ever waiting for an app store to approve it. Now, the secret sauce making all of this work is containerization. Think of it like a highly advanced virtualization tech. When a mini program loads up in your host app, it's placed inside a perfectly sealed secure sandbox. It gets its very own independent threads and its own secure local storage. One mini program cannot see or mess with another. This incredibly safe isolation is the key. It allows your platform to scale up infinitely without the fear of your entire app crashing just because one single feature glitched out. Let's move to Section 5, building SuperApps with FinClip, creating the assembled app ecosystem. Imagine taking your user's experience and transforming it into a massive digital ecosystem, functioning exactly like a box of snap-together Legos. Instead of wrestling with a giant monolithic codebase that slows everything down, an architecture like FinClip lets you deploy a lightweight native shell that can host dozens of independent mini-apps. We're talking everything from financial services and shopping to travel and utility bills, all in one place. You are essentially running your very own private app store right inside your main application. For all the product managers watching, this visual, plug-in-driven architecture is a total game changer for agility. By breaking development down into these modular chunks, teams are seeing huge efficiency multipliers. We're talking 4 to 6 times faster than traditional methods. Because you aren't waiting around for massive, risky code deployments, you can iterate on individual business functions instantly, adjusting on the fly based on what your users actually need right now. And it gets even better. This approach can slash coding barriers by up to 80%. That completely shatters traditional development silos. It means your entire team, whether they're designers, product managers, marketers, or even external third-party developers, can all directly jump in and participate in creating these mini programs. It adapts perfectly to whatever resources you happen to have on hand. Finally, Section 6, the future of assembled apps. We're talking infinite scalability and open frameworks. The big takeaway here is that by combining mini programs with an open, custom plugin market, you create a high-experience assembled app that literally never stops evolving. Let's be real, it is impossible for one single enterprise to build every feature a user might ever want. But by choosing a truly open technology stack like FinClip's app market, you let third-party developers do the heavy lifting for you. A great example is the Agora plugin, which drops immense customized functionality right into your lap. You just build the robust foundation and watch the ecosystem organically grow. I want to leave you with that thought to ponder as you start planning your next major software architecture move. Ask yourself, are you building something that will eventually buckle under its own weight, or are you assembling a dynamic ecosystem that's built for infinite scale? Thanks for joining me for this explainer, and I really hope this gives you a completely fresh perspective on the incredible power of mini programs and custom plugins.